And so we'll get started with our first lightning talk session here. And first up, we have Ganhua Lu, who's going to talk about whose title is Harness Data to Improve Health Equity for Communities. Go ahead.
Thanks, Sarah, for the introduction. And good afternoon, everyone. So I'm Ganhua. I'm a data analyst from County Health Rankings and Roadmaps. County Health Rankings and Roadmaps, or CHRR, is a collaboration between UW Population Health Institute and the Robert Wood Johnson Foundation. So we aim to help improve community health and close gaps between those with the most opportunities for good health and those with the least opportunities for good health. So basically, we are a data to action platform. So we use data to rank the health status of counties across the country. And we work to spark conversations and actions for communities to improve their health. And we also provide communities with guidance and tools for them to take actions in building sustainable, healthier communities. And every year, we release county health rankings. This annual release is one of the most important data products we have at CHRR. Slide, please. Next slide. Thank you. No, it's okay. So, we started release health county health rankings from 2010. So over the past 10 plus years, we have collected, cleaned, and prepared some large volume of data. And these data are from various sources. So next slide, please. And these data sets, they cover a quite broad range, quite broad spectrum. This is because many factors impact population health. So obviously, clinical care and health behaviors are important health factors. So we have data from CDC, HRSA, but on the other hand, social and economic factors such as employment, education, poverty, these also impact our health. And the physical environment such as air, water quality, housing, transportation, they affect our health as well. So we use data also from US Census, EPA, USDA, and other agencies and organizations. So next slide, please. Now the rich data sets have supported our work on county health rankings. And currently, the rankings are calculated based on a pre-designed model. So next slide, please. And the data and the rankings help us with population health research and evidence and policy analysis. And also the rankings provide a source of local evidence to communities. And they can use them to identify opportunities for improving their communities. The rankings help us to engage community leaders and help them to make data-driven decisions and take actions in building better communities. And this is just a quick overview of what we do at the CHRR, and mostly from the data perspective. Next slide, please. Now we are looking for partners to explore some very interesting data-related questions. And these questions will have some meaningful impacts on health equity for communities. And for example, currently the rankings are calculated using a pre-designed model. So how about we start from data? So maybe let's develop models based on the data for not only descriptive analytics, how about for predictive or even prescriptive analytics using the data. And also we must deal with missing values and different sample sizes. So we hope some of you would like to share your expertise and experience with us and ensure that our methods are robust enough to handle these situations so that our findings can be used in places with widely different populations, from counties with millions of people to counties with only a few thousand people. And please contact me or my supervisor, Christine, if you like to be partners with us or have any questions. And please visit us at countyhealthrankings.org if you want to know more about us. And if you want to explore our data, it's available there. And thank you very much. And please join me in chat in about 30 minutes. And my time is up. Thank you.
Thank you, Ganhua. Next up for lightning talks. Oh, and I should tell everyone you can virtually thank our speakers using the reactions at the bottom, where you can give them a virtual round of applause like this. Thank you. Next up for the lightning talks is Jinmeng Rao, who's going to talk about, or whose title is VTSV, a privacy preserving vehicle trajectory simulation and visualization platform using deep reinforcement learning. Go ahead, Jinmeng.
Okay, thank you, Sarah. So hi everyone, nice to meet you. This is Jinmeng Rao from Geography Department, supervised by Professor Kesong Cao. Today my talk is about VTSV, and this is the title, so I don't need to repeat that. And so first is a motivation. Next slide, please. Nowadays in trajectory research, we only have limited data accessibility of the vehicle trajectories due to the privacy concerns, because usually users don't want to share their data with others. Also, consequently, we have the data sparsity issues and data imbalance issues. Next slide, please. So in this research, we want to design a platform to simulate the customized synthetic vehicle trajectory, which can create tons of diverse vehicle driving data without privacy issues. So next slide, please. So here we present the VTSV platform to do this. And this is a framework overview and the interface of the platform. So as you can see, the platform has 5 components. Next slide, please. So the first one is a route planning module, which plans a route, giving an origin and destination. And here we use OSRM to do this. Next slide, please. The second one is the privacy protection module that ensures the simulated trajectories that do not cause the privacy concerns. And we integrate 2 techniques here. Next slide, please. So the first one is the geomasking, which just means we randomly shake the coordinates. Next slide, please. And the other one is the K-anonymity method, which generates multiple trajectory alternatives, and people cannot distinguish a specific one from the others. Next slide, please. The third one is the driving simulation module. So in this part, we utilize a artificial intelligence algorithm called deep reinforcement learning to do this. Next slide, please. So in brief, to simulate the drivers with different driving behaviors, we use this deep reinforcement learning to do that. By talking about the different driving behaviors, we mean like the normal driving behavior or aggressive driving behavior. And after the training, we can use the drivers to interact with our virtual environment to produce the diverse driving data based on the given routes. Next slide, please. The final 2 are the data visualization module and the data export module, which can help people better understand and utilize the simulated data. Yeah, next slide, please. And also next slide. Yeah. Thank you. So these are the screenshot taken from the VTSV platform. So the picture in the upper left shows the simulated driving data from our platform. We have, as we can see, we have a map panel showing the roads, and actually there's an animation showing how the car drives along this road. Because this is a PDF version, so it cannot be played. And we also have some light charts showing how the speed, acceleration, and steering angle of the vehicle changes over time. And given different parameters, user can actually customize the different driving behaviors. So the other 2 pictures just show how to use the integrated 2 privacy protection techniques. Next slide, please. To sum up, in our research, we propose a platform that can simulate the vehicle trajectories with different driving behaviors while avoiding the privacy issues, which we believe could be beneficial for many applications, such as the traffic simulation, self-driving, and mobility research. That's all. Thank you for your attention.
Thank you, Jinmeng. And next up, we're going to hear from Kesong Cao about Hugging Face, which uses NLP and more. Go ahead, Kesong.
Hello, everyone. My name is Kesong. I'm a first-year graduate student at the psychology department in the cognitive area. My current research interest is humans' cognitive ability to categorize objects into some more abstract classes, especially in vision and language. Recently, there has been a growing interest from the psycholinguistic community and sure many other disciplines to learn and use machine learning approaches in their own research. For example, we now know that humans and machine learning models, when classifying an object from an image, rely on different aspects of the object. So humans, at least in some English-speaking societies, rely on the shape of the object to make a decision, and models would tend to use more of the texture or material of the object And why is there such a difference? To look into that, researchers like me would need to learn in details how a machine learning model works. Therefore, today I'm introducing you a very useful open source community for machine learning people. And that, as I will show you briefly, it's very easy to get started, and it contains a lot of useful resources to help you get along the journey of learning natural language processing and maybe computer vision too. Next slide, please. So the website is called Hugging Face. The name comes from its emoji logo. It was started some years ago, initially focused on just natural language processing, and Hugging Face was trying to build their own pipelines for NLP models called transformers. The transformers is very complex, and I'm not going to explain in detail today, but the things you should know that those models are very large and often costly to train, and the new models are coming every day, and managing your own models could be in your own research project would be messy and sometimes painful. So Hugging Face created a model hub where users can upload their models to the website. From there, they could easily run, train, and deploy their own models using their the Hugging Face code base and APIs. Because it is open source, lots of people outside Hugging Face has been contributing to their code base. And now it has become a full ecosystem for NLP, and it's growing to computer vision too. So in order to train a model, to run a model, one would just need to know the basics of Python. But of course, training a model by yourself would take more efforts, and it would be good to know a bit about machine learning framework like PyTorch or TensorFlow. Next slide, please. So let's do some language modeling. You can see here in the code snippet, it only takes 3 lines of code to perform this task. So you select a model from Hugging Face, and you select a task, which here is to predict the what's the word in the mask in the mask, and you can see that the model predicts happiness would be the most probable word in this sentence. And although the answers in the right is a bit religious, but I guess it's fairly reasonable, and it can also show the probability score. Next slide, please. Of course, but training will be more tedious, but also it's not too long, and just choose model your arguments and leave your code running and see some dog or cat pictures. Again, you can find documentations you need using the link below. Next slide, please. There are plenty of resources on the website, and I'm sure you could find something interesting to you or useful to you. If anyone interested in wanting to learn more, please let me know, and we can talk more in the breakout room. Thanks. Yeah, that's it. Thanks.
Thank you, Kesong. Next up is Yuhao Kang, who's going to talk about multiscale dynamic human mobility flow dataset in the US during the COVID-19 epidemic. Sorry, reading a lot today.
Thank you, Sarah. Hi, everyone. Good afternoon. This is Yuhao Kang from the GeoDS Lab, Department of Geography. So, during the COVID-19 epidemic, our team built a multi-scale human mobility flow dataset in the United States. And today I would like to introduce the proposed dataset because we hope it can enrich our understanding of human mobility patterns and contribute more, not only for fighting the pandemic, but also benefit some other applications such as urban computing or transportation. Next slide, please. The COVID-19 has and may continue to be a global threat to the public health and human societies. While social distancing has been proved as the most effective non-pharmaceutical intervention, tracking dynamic human mobility changes and spatial interaction patterns is therefore a prerequisite. Our GeoDS lab have built an online interactive web portal to monitor human mobility changes. And as you can see that at the beginning of the COVID-19, because of the stay-at-home orders, the mobility of people reduced significantly, as these blue regions indicate that people reduce their mobility or reduce their movement significantly. Okay, next slide, please. Such a platform was empowered by a high time resolution human mobility dataset as a multiple scales. It contains origin to destination mobility flows at both weekly and daily, and at 3 spatial scales that includes census tract, county, and at the state level. The data is produced from March 2020 to now, and the live version of the dataset is still available on GitHub. So you can check our GitHub, the link. And as you can see, there are 2 columns of sample data. We provide the GeoIDs of each region as a unique identifier. And the last 2 columns are visitor flows based on SafeGraph data and estimated population flow that we calculated. So we think that this product can be used as human mobility flows directly in all kinds of research or studies. Next slide, please. I will also want to show some statistics of our mobility dataset. So these figures show the temporal changes of mobility flows in 5 metropolitan areas in US. And the changing patterns is obvious. With the progress of the pandemic, human mobility decreased significantly from mid-March to April 2020, and with a slight increase in May 2020 because of the reopening. Next slide, please. And these figures show the spatial patterns of human mobility patterns during the COVID-19 from origin to destination. As you can see, that the movement flows decreased significantly from March to April 2020 due to the stay-at-home orders. On the left 2 columns, well, with certain increases in May 2020 because of the reopenings. So next slide, please. So we also compare our data set with some other openly available data source to check the data quality. As you can see that the produced mobility flow data set have high Pearson correlation coefficients with another openly available data set called DCAS Lab mobility changes data set. So that means these 2 data sets have similar mobility temporal change patterns. Although there is no ground truth data to characterize which data set is more accurate or not, such comparison still provides insights that our mobility data set can capture the mobility flows and can be used. Okay, that is all. Next slide. That is all for my presentation. And if you have any questions regarding the mobility flow data set, please feel free to contact me. That's all. Thank you.
Thank you, Yuhao. The next lightning talk is by Brian Yandell, and it's about Shiny. It's called Shiny App Shiny App at Scale using RStudio Connect and ResearchDrive. Go ahead, Brian.
Okay, thank you, Sarah. It's nice to be here. This is work that was motivated by collaboration with Alan Addy, professor in biochemistry, and extensive collaboration with Carl Broman in biostat medical informatics, and also Gary Churchill, who's at the Jackson Labs in Maine. Next slide, please. So you'll notice at the bottom, there's a link down here. You can get the slides and extensive extra material in here. So the question, the research question that came up is, what are the genetic drivers of diabetes? So, and obesity. So why do people become diabetic? What's going on there? And there's a strong connection between diabetes and obesity. And underlying that, there's got to be some sort of changes going on in the body at a molecular level. So, people started out with just looking at gross measurements of the body, like insulin and glucose and weight and other things of that nature. And they moved on to measuring genetic signals and also proteins and other kinds of molecules. So I'm just going to highlight a tool that allows people to start integrating these things and look in detail. So the goal is to put the tools in the hands of researchers. I can develop tools, but if I hand them off as a GitHub resource or as a package I send them in the mail, and then data they've got to connect together, it just becomes a very complicated task for someone who's used to working with web interfaces. So that's why I'm thinking about Shiny. So the challenge is that tools get complicated and the data are big. And we're aiming towards a solution of developing interactive Shiny app and how to link and then trying to put it on RStudio as a way to put it on the web. So you'll see here an example of data where there's a large region, but the main focus is on this area where there's a high peak. So we want to zero in on a small part of a large data set. So let's go to the next slide, please. So in putting this together, we have this large data, many gigabytes of data stored in some place that's accessible, such as a ResearchDrive, and then ways to pull out small pieces of that. And then a human, by this smiley face, is going to use a web interface to get access to all these tools. And my Shiny apps called QTL2 Shiny is a way to integrate all these together. So it draws on various R packages as well as some QTL packages that build off of work by Carl Broman. And then there's some other bookkeeping things called the manifest to make sure things are up to date. So putting these all together is one of the challenges, and making them work interactively and dynamically. Next slide, please. So here it gives you a picture from this app, and there are multiple ways that one can do this. The easiest thing is, from my perspective, is to have it on my laptop and run it. That's the fastest thing to do. I've got the data on the laptop. I've got the or on the ResearchDrive and run the apps. But I want to put it into RStudio, and the challenge there is, how do you upload the data, and how do you work with it remotely? So you can get some idea from these screenshots about how to work with this, and of what the capabilities are, and I can show some more when we get to the demo. We still have some challenges to put all this in place, and we'll look forward to talking with you further. I've been working with DoIT on the details of this. Thank you.
Thank you, Brian. Next up, we have Leah Haman, and she'll be talking. Her talk is entitled Beyond Academic Research, Commercial Value of Data Sets and Software. Go ahead, Leah.
Thank you, Sarah. So we have already seen some great talks from researchers who are looking into some really challenging problems and answering some critical questions. So while they're doing this, there's often vast amounts of data that is collected, measured, observed, analyzed, compiled, and at some point probably cleaned up in order to then do some analysis and report out on the findings. And the cycle may repeat because that analysis might have shown that there's some new questions to look at. So while this interesting research is being carried out by our wonderful UW-Madison faculty, our scientists, our students, something to consider is, can parts of the research move beyond the academic umbrella? So data, among other research assets, such as patents or software tools, trained models, are all of interest to companies that are outside of the academic research space. And that is where WRF can help. So we don't do research, but we work in the world of technology transfer, where scientific research is moved out of the university setting to companies and entities so that it can be translated into new products and services that can benefit society. So WRF is the Wisconsin Alumni Research Foundation, and we are a not-for-profit supporting organization, and we are UW-Madison's dedicated technology transfer office. And we use legal agreements called licenses, which contain terms that the parties agree to in order to legally define this transfer. And then typically there's a fee paid in exchange for the right to access or use the intellectual property or the assets. And those fees can be negotiated, and it can really vary based on the technology. But why is technology transfer beneficial, and why would licensing be beneficial beyond just seeing some work get out there? Well, when there are fees involved, those fees are benefiting not only the researchers personally, but they also benefit and aid in WRF's mission, because we're able to invest it. And we then are able to grant annually a financial gift to UW-Madison to support more research. And some examples are shown here. In addition, something to consider is that licensing innovation would include terms that would allow researchers to continue on in their research. And it also would outline what a company is able or not able to do with that innovation. So it might allow companies, if they're licensing some software, to make derivatives, or perhaps it would prevent a company from making a derivative of that software. So the goal is that we would be able to help with that transfer when needed, and that we would be able to put some terms in place that would appease everyone and would help get that innovation out there. So no matter what stage your research is in, what field you're working in, we would be happy to discuss what we might be able to do to help you beyond maybe the traditional, can we patent your innovation? And so we are particularly interested in meeting with researchers who have either data sets or other tools that might have commercial value. We have successfully licensed innovations in the past, including patents and software tools, and including data. And certainly we know there are unique factors that we have to look into further. If there is a case where it makes sense for work to get involved, we work with our researchers and our UW administrative counterparts to try to creatively move your assets out into the world. So hopefully today in the breakout room, some people will want to learn more about tech transfer. Thank you.
Thank you, Leah. First up for this round of lightning talks is Keyi Wang, who's going to tell us about machine learning towards more inclusive technologies. Go ahead, Keyi.
Hi, I'll go ahead and get started. Could you hit the next slide? Okay, thank you. So when we think about when AI gone wrong, we mostly hear of stories like how a kidney transplant algorithm went wrong and blocked the Black patients from getting a kidney transplant, even if there is a match. You might also have heard of the example of facial recognition technologies not working well with Black faces, as well as algorithms are biased against people of color when processing job applications. Next slide, please. However, it is only fair to note that the developers of these algorithms are not evil programmers who have the intention of building tools that will affect the lives of underrepresented groups. The issue comes with the misrepresentation or underrepresentation in the data collection process, which explains why minorities are being affected the most by AI technologies. Not only in the data set, minorities are also not involved enough in the development process. Among the number of computer programmers, around 70% of them are white, 15% of them are Asians, and only around 5% of the programmers are Black. With a less diverse group in the development process, issues like this are less likely to be identified. Next slide. This is what led to the launch of AI for Africa. I am Keyi, and I am the head of operations of AI for Africa. The aim of AI for Africa is to create a more responsible, equitable, and accessible technologies. Some of the ongoing projects at AI for Africa include a chatbot capable of answering mental health and menstrual health questions. We are also actively collaborating with nonprofit organizations such as Care International and Days for Girls to provide them with the technologies they needed, such as websites and mobile applications to make a local impact. Moreover, we're working on a machine translation system that could translate between African languages. For the past year, we created a successful machine translation prototype for translating between Twi and English. We've reached a very high level of translation accuracy, and we attain the best model performance in the world for translation in Twi. Throughout our working process with machine translations, we noticed a fair amount of problems existing. In order to devote more time and energy into this language translation initiative, we want to officially launch it here at the Research Bazaar, our African Languages Lab. Next slide, please. The African Languages Lab will be focusing on curating, cleaning, digitizing, and translating between African languages. We hope to create a roadmap of technologies and methodologies for African languages. We will devote our effort into collecting resources of translation pairs, as well as conducting research on machine translation models, aiming to further improve on the translation accuracy. We also plan to strengthen our collaboration with the Language Resource Center both in Africa and in the United States to integrate all of the available resources for African languages translation and education. Hopefully, we will be able to encourage communication and online presence from more African communities and further improve on the diversity of the data set for machine learning models to learn from. And next slide, please. Finally, we would like to thank all of these departments and programs for their help to push this initiative forward. Thank you.
Thank you, Keyi. Sorry, I forgot to put my timer up there. The next talk is by Iliana Wood, and I will get my correct background up for your timer. Thanks for asking, and I got some messages reminding me. And Iliana was telling us about scaling the collection and interpretation of public benefit policy eligibility, challenges and solutions.
Hi, I'm Iliana, or I also go by Lana Wood, she, her pronouns, and I am the founder and CEO of Parsley, which is a public benefit corporation here in Madison. We have strong ties to UW-Madison. We were born out of the Dream Up competition that was hosted by UW's Institute for Research on Poverty and funded by Eric and Wendy Schmidt. And we're also partnering with the Data Science Institute to address some of the challenges that we're talking about today. Our mission is to promote the economic flourishing of working people through the development of data-driven technology. And we're doing this by leveraging a large amount of public benefits eligibility data to help people make better career and financial decisions. Next slide, please. So the main problem that impedes people making those decisions is the fear of what's called a benefits cliff. And that is when a person increases their income, maybe through a raise or a new job, or maybe working more hours, but that wage increase causes them to lose eligibility for public benefits. And if they're using supports like Medicaid or rental assistance, it could result in a net income loss because their raise doesn't cover the benefits that they lose. So it could be like gaining earning $1 more, but losing $3. Next slide. Our team found that this isn't just an issue if you face a cliff, but part of the issue is also not knowing if you will face a cliff. And so there's really no way to even begin to calculate how much you need to make to break even if you don't have access to the information about when you'll lose eligibility or how much you'll lose. Next slide. And there's not one place that a person can go to get this information. It's all in different programs. They have different requirements. They're stored in different places and they measure eligibility differently. So the choice is to take a leap of faith or try to navigate that path on your own with all of this information that's technically publicly available, but not accessible. Next slide. So to address this, we are creating a net income calculator that's powered by a database of all of these rules that is contextualized around a user's unique family situation. So our challenge is scaling this with the level of data that we have to incorporate. Next slide. One of the challenges we'll face is just the sheer volume of data and the state that we find it in. Most of these policies are stored in PDFs and they're not easy to find in any sort of streamlined way. And so to address this, we are thinking about some NLP solutions, as well as creating an open source UI that would be available for non-programmers to enter eligibility rules into our database. Next slide. And we also need to think about building for volume and variety, that we're not just housing these government programs, but lots of other types of information that we want to use in different ways in the future. Next slide. As well as performance issues, anticipating the volume of data, the number of users, and also building effective validation methods and processes to make sure that we find any errors and are able to fix them quickly. The next slide. So we're here today hoping that you'll join us in conversation, seeking collaborators and connections and ideas. If anybody wants to talk more with us about these challenges and how we're solving them. And if you have any insights, we would love them. Next slide. And on that note, we are hiring a senior data engineer. So if you or someone you know would be a great fit for this and believe in this mission, can check it out on our website, and which is www.yourparsley.com. And next slide. And just this slide is just showing that we're hoping to create a path for people to make sense of all that data so that they can actually use it to their advantage to move forward and for economic success. Thanks.
Thank you, Lana. Next up, we have Nancy Sheehan, who will be telling us about meeting FAIR principles, challenges and successes from a citizen science program.
Hello, everyone. Good afternoon. Yes, I'm Nancy Sheehan, and for the next 4 minutes, I'm going to run through and share with you my experience meeting FAIR guiding principles in data management. I am the program coordinator of Journey North. So next slide, please. So Journey North it was founded in 1993. It's a crowdsourced citizen science program that's designed to collect spatial and temporal data on wildlife migration. It's a program that is powered by volunteers. We have had over 100,000 volunteers across North America submit 600,000 observational reports on 30 migratory species. Our biggest projects are our hummingbird and our monarch butterfly migration projects. I started coordinating Journey North in 2018. I dug deeply into the database and found really this was a treasure trove of data that could contribute to migratory science. Next slide, please. But to really reach the potential to contribute to science, there needed to be greater transparency. So I made it my goal to ensure that there's 25 years worth of volunteer collected data was widely available now and into the future, the next 25 years. I will say that volunteers, some of our volunteers have been with Journey North now for the full 25 years, and they're very much motivated to contribute data that is meaningful and actionable that can contribute to science. So it wasn't necessarily required by any funding source, but it was more of an ethical obligation to those volunteers to make the data findable, accessible, interoperable, and reusable. So next slide, please. So my challenges were great. Journey North did have the data, a portal for public to view the data. One could download it, but access was difficult. If researchers were interested in a particular data set, there was a gatekeeper. Usually they would have to contact me. There'd be a lot of back and forth inefficiencies. Discovery was through more informal channels, so no metadata documentation in terms of use or privacy policy. And the biggest challenge was that I came into this job without academic background in data management or data engineering. So there was a lot of that I had to bring to the table and learn. And I will call out, oh, next slide, please. That I did have some critical assistance. So there are practitioner networks for those of us working in citizen science, the Citizen Science Association and the European Citizen Science Association, that is really supporting leaders to think deeply about data management. Oftentimes we're very focused on recruitment and volunteers. I'll mention the Data Science Hub and the Environmental Data Initiative. And I'm going to move fast to the next slide because the success was that we published 2 data sets with the help of a fellow who came through us through EDI. We now have 2 data sets, metadata documentation methods. Each data set has a persistent and unique ID. And what's important for me is that it's a repository for the future. So this data set will be there regardless of where Journey North is. The citations are provided that recognize volunteer effort, terms of use, and privacy. So if you're interested, I'd like to be part of your network of support, especially if you are in the citizen science field. If you are like me that have really had to learn on the job, I'm here to support your efforts. So thank you very much.
Thank you, Nancy. Next up, we have Cameron Cook, who's going to tell us about data repositories at UW-Madison.
All right, hello everyone. I'm Cameron Cook, the Digital Curation Coordinator and Chair of Research Data Services. And I'm going to give a brief overview of the centralized data repository memberships and services available to campus researchers. So data repositories provide critical infrastructure for sharing data sustainably. They're able to do so because they provide centralized access to data sets, which are then cared for by a committed third party and stewarded, made discoverable, and made accessible for the long term. While there are many great community or discipline-specific repositories, not all researchers or disciplines have access to them, and so I'll be focusing on some of the broad campus repository memberships and services. Next slide. Sharing data has become a common feature of the research landscape for a lot of reasons. We're seeing a big rise in data sharing, not only from the initial impetus of the federal funding requirements, but increasingly because publishers are also requiring it. We've also seen increased pressure to share to speed discovery during crises such as COVID-19. There are also a number of reasons to share, including enhancing transparency, reproducibility in your research, and just sharing resources. Next slide. Another forthcoming pressure that will be a change for campus researchers is the forthcoming changes in NIH data sharing requirements. These build on previous data sharing requirements, but will require a broader swath of NIH researchers to share, require sharing more data and sooner, and lays out further guidance on human subject sharing, among a couple other things in their policy. They also recently announced a new initiative, the Generalist Repository Ecosystem Initiative, which announced 6 generalist repositories they are working with that will then supplement NIH's very specific subject repositories to help address these forthcoming changes. Next slide. So lucky for us, one of the repositories that they are working with is a repository called Dryad. UW-Madison joined Dryad as a member institution last summer. With our membership, researchers at UW-Madison can deposit up to 300 gigs per deposit for free into the repository. They have a number of great features, including integration with a number of major publishers and journals, the ability to upload code, scripts, and software, and basic curation of all submitted data sets by Dryad staff, and some more features on top of that. Next slide. Another centralized repository resource for campus is Minds at UW, our institutional repository. We're able to take data alongside other supplementary files from your publications or research. And because we take so many scholarly outputs of any type, it's a great option for those who would like to have their own collection and have their preprints, data, supplemental materials, conference posters, etc., all alongside one another. We're also currently in the process of beginning to launch a pilot that would use Globus in combination with Minds to make data sets of up to 1 terabyte publicly available to comply with funder and publisher requirements. We've had a few successful test cases, one of which is shown here, but we're still finalizing this pilot and we'll share broadly once it's available. Next slide. And finally, I want to share another campus repository membership. This is not a generalist repository. ICPSR is a centralized resource for campus researchers working with social sciences data. We are a member institution, and their data repository provides a number of beneficial features, including curation by ICPSR staff, ability to provide varying levels of restricted use and access to the data, and then providing usage information. Next slide. And finally, I just want to end by sharing that if you have any questions about these repositories or you aren't sure which is the best fit for you, Research Data Services is available to help. You can contact us through the form on our website, which is linked here. Next slide. And then here is my contact information on our website once more. And that's it. Thank you.
Thank you, Cameron. Next up, we have Matthew Fikert, who's going to tell us about publishing statistical models, getting the most out of particle physics experiments.
Yeah, hi. Thanks for restarting the time. Hi, I'm Matthew Fikert, and today I'm going to be introducing you to the particle physics community and sharing some of the work that we're doing to try and get the most value out of particle physics experiments. So next slide, please. Sorry, next slide, please. Okay, thanks. All right, yeah, so particle physics is kind of magic as we have tool. Oh, sorry, maybe there's delay in my slide. And can you go back to like the first slide that actually had content on it? I'm now seeing, oops.
This is the one, high energy particle physics at HLC.
Yes, thank you.
Okay.
Yeah, there we go. Yeah, sorry about that. I think there might have been some delay. Anyway, so particle physics is kind of magic as we have tools that give us not only a window into the conditions of the very, very early universe, but also allow us to recreate these conditions billions of times to study the fundamental aspects of natures. And experimentalists like me have forged multi-thousand person collaborations to build these machines like the CERN Large Hadron Collider, which we see here on the left-hand side in a cartoon form just outside of Geneva, Switzerland, as well as the Atlas detector shown here on the right-hand side with the T-Rex for scale. And we also collaborate with our theorist colleagues who have worked really hard to distill nature into mathematical models that with enough manipulation can fit on the side of a coffee mug, as we see on the lower left-hand side. And we're all doing this to try and search for new particles that can tell us more about our universe. But we have a bit of a communication problem. Slide 3, please. Okay, yeah, thanks. So historically, because of the complexities of scale, the complications of scale, complexity, and technical infrastructure, the statistical models that experimentalists like me use in our physics analyses get scaled down and simplified when they're published alongside of our papers to data repositories as FAIR, which as we already heard from Nancy, it means findable, accessible, interoperable, and reusable data products. And we do this to make the models easier for theorists to use in their work without having to know all of the experimental complexity. However, your model is your hypothesis. And so when we simplify our models, we lose information and make the kind of dialogue or flow of experiment and theory information a little bit, and data a little bit lossy and a little bit opaque. Slide 4, please. However, some of my Atlas experiment colleagues and I recently found a way to start publishing the full statistical model as FAIR data products. And as you might be able to see here on the left-hand side, they even get their own model-specific DOI, which is pretty cool, in a format that the theorists can still find, understand, and use with some help of some new software tools that we developed. And this has really taken off. So we went basically from no full models 2 years ago to now over 18, and the demand is still growing. Slide 5, please. Slide 5, please. That should be the one with the paper on it. Yeah, thanks. Okay, so seizing on this opportunity, the particle physics community has come together from across theory and multiple experiments to try and create some guidance, recommendations, and requests for the particle physics community to try and publish as many full statistical models as possible. And we've posted this on the archive as a preprint, and it's now also available as an open access SciPost physics publication. Next slide, please, slide 6. Yeah, OrcIDs. Yeah, thank you. So our goal is to try and continue on this work that we've been doing over the last 2 years to try and make sure that we can improve the dialogue between experimentalists and theorists, and to try and make this as clear and robust as possible. So now with the full models from the experiment coming out, the theory and information exchange and communication should get even better. Slide 7, please. Okay, but our community wants to learn from you. So that we're not done with our first publication that talks about this. We want to try and learn from other communities that have gone beyond us. So if your community publishes large open data sets, has navigated the nuances of publishing technical data products, you've solved intra-community communication issues around data products, and you also support shared global data and software infrastructure, we want to talk to you. So on my final slide, I just want to say thanks for listening, and please come talk with us. There's contact information there. Thanks very much.
Thank you, Matthew. Next up, we have Jennifer Patino, who's going to tell us about resources for learning about data equity.
everyone. I'm Jennifer Patino, she, her pronouns, and I'm the Data and Digital Scholarship Librarian with Research Data Services. Today I'm going to talk to you about our Practicing Data Equity series and the resources we put together to learn more about important topics in this area. And I'll just go ahead and drop our link in the chat real quick. All right, awesome. Next slide, please. All right, so my definition of what practicing data equity means is acknowledging the data is not inherently objective and taking steps to ensure equity in our practices and our relationships. So our decisions about how data is collected, analyzed, and used can impact real communities and people. So it's important that we learn to evaluate our processes as well as any data we might be reusing and work to make our relationships with communities equitable. I'll start off with an example of what data inequity. So data inequity can look like from one of our resources. Next slide, please. In 2020, the Pew Research Center came out with a study on the use of the word Latinx. For those of you who don't know, Latinx is the term that's been adopted by members of the community who wish to be more inclusive of gender diverse Latinx people, especially those who are non-binary. From the qualitative data in the study, you can see that people associate with inclusivity of gender diversity or LGBTQ plus Latinx people, and they either have neutral or positive feelings or very strong negative feelings about it. Next slide, please. So the study concluded that only 3% of Latinx people use the word Latinx, but who are they actually talking about? We get a breakdown of the demographics from the study, and in gender, you can see that they only have women and men listed. So I'm sure we can see what's wrong with collecting only 2 genders in a study about a term associated with inclusivity of non-binary Latinx people. We can also see that information on sexual orientation doesn't appear to have been collected, so we don't get a sense of the overall participation of LGBTQ plus Latinx people. The erasure in the study of the people the term is most associated with can cause a lot of harm, as it's been written about widely in both English and Spanish, as proof that the term shouldn't be used. Data equity in the study would have looked like establishing a relationship with members of the community that the term Latinx actually was designed to be inclusive of, and designing the study in such a way that their perspectives were included. Next slide, please. Last year, we kicked off our Practicing Data Equity series on our RDS blog, publishing introductions to topics in data equity and resources for delving deeper. Our first post, written by Cameron Cook, was the CARE Principles for Indigenous Data Governance. These principles were created by the Global Indigenous Data Alliance and consist of collective benefit, authority to control, responsibility, and ethics. Because the open data and open science movement focus on data sharing alone, the Global Indigenous Data Alliance felt that this can ignore historical context and power differentials and doesn't meet the needs of Indigenous communities who are asserting control over the use of Indigenous data and Indigenous knowledge for the collective benefit. So the CARE principles were created and are meant to be a complement to the FAIR principles and help users take people and purpose into account. We also share some tools to help evaluate the worldview that we bring to research. The data equity framework from the We All Count Project for Equity in Data Science gives a 7-step process for evaluating different elements of a data project for potential equity issues and solutions. And then in our post that highlights community-based approaches, we share the principles for advancing equitable data practices by the Urban Institute. They argue for applying the Belmont Report's 3 principles for protecting human subjects, which are justice, respect for persons, and beneficence, in a way that also considers collective harm in addition to potential harm to individuals. They also have this great data walk methodology for engaging community stakeholders in dialogue about research findings about their community. We also shared the toolkit for centering racial equity throughout data integration, which was created by Actionable Intelligence for Social Policy at the University of Pennsylvania. This toolkit looks at cross-sector data sharing and integration and how it can turn individual level data into information to support community needs, or how it can be used to reinforce racist policies and inequity, and gives tips. And lastly, we put together a post on the issue of data visibility and the need for disaggregation of data for marginalized communities. And in that one, I wrote about the harm that treating communities as a monolith or lumping them into 5 or 6 broad categories can cause, including the example of the study I mentioned earlier. Next slide, please. And so, yes, so if there are any topics you'd like to hear about or any resources you'd like to share, please let us know. You can find us on Twitter at this handle, or you can email me directly. Thank you so much.
Thank you, Jennifer. To get us started for this round, we'll be hearing from Lauren Michael, who will be telling us about Research Computing Beyond the Desktop, the Center for High Throughput Computing. Go ahead, Lauren.
Thank you, Sarah. My name is Lauren Michael. I lead research computing facilitation at UW-Madison and the Center for High Throughput Computing, which serves as UW-Madison's core research computing center. And this role on campus is really built on our history of worldwide leadership in the research and development of technologies for large-scale computing. We offer computing systems along with ample human support and learning resources to accelerate and transform your work. Access to CHTC services, including nearly all of our capacity, is free of charge to UW-Madison affiliates and direct collaborators, with rarely needed options for purchasing capacity prioritized just for you. In the last year, more than 1,000 users from hundreds of research groups all over campus used CHTC, and you're even hearing from some of them today. The computing time we delivered in the last year is equivalent to running a laptop for 35 millennia, and individual users have achieved up to millions of computing hours per year to accelerate their work. Whether you need to run large numbers of computational tasks, need to run high-resolution simulations, have large data sets, have complex workflows, or your work is just starting to take too long on your current computer, CHTC can help, either by helping you use our own computing systems or by pointing you to other on and off-campus services that we coordinate with. Advanced slide, please. CHTC integrates multiple sources of computing capacity, all via a single interface that we teach you how to use. You can access not only CHTC's computing capacity, but can scale up to additional pools of capacity on campus and beyond, including cloud and nationally allocated computing systems, all from a CHTC submission point that you access from the comfort of your laptop. We teach you how to automate your work and easily scale up to as many as thousands of computing tasks running at once using the HT Condor software, which is developed by CHTC and used all over the world by campuses and companies, including organizations like DreamWorks, SpaceX, and the FBI. Often, researchers using CHTC find that they can not only tackle their current work more quickly, but that they are able to transform the way they tackle research problems, opening the door to bigger and more complex projects. If you'd like to learn more about some examples, check out our poster later today. Advanced slide, please. In order to make sure you are successful, we have a dedicated team of research computing facilitators, a novel staffing model that originated at UW-Madison in CHTC and that has taken off nationally. If you're new to CHTC, you'll first meet with a facilitator like myself to discuss your computational objectives, determine expected computational output per your learning investment, and define a personalized startup plan. Rather than being experts in computing, which we have plenty of, facilitators have significant research, communication, and teaching backgrounds, serving as the human interface to CHTC through our ongoing email support, drop-in office hours, and online learning materials. By empowering you to achieve research impacts yourself, we help you to realize new possibilities through computing. And we're happy to talk about resources outside of our own. Learn more and talk with our facilitators at our poster later today, or by going to chtc.cs.wisc.edu to access our services. Thank you.
Thank you, Lauren. Next up, we'll be hearing from Laura McCulley, who will tell us about the Survey of the Health of Wisconsin, a statewide community health data resource.
Hi, I'm Laura McCulley. I'm the communications specialist at the Survey of the Health of Wisconsin, SHOW. Today I'm going to share with you the challenges that COVID-19 posed to SHOW's typical research processes, how SHOW is able to overcome those challenges, and capture insights into how communities in Wisconsin are affected by the COVID-19 pandemic. SHOW is an established health research survey that includes a representative sample of residents from across the state. Previously, SHOW field staff spent long periods of time around our families in their homes collecting data in a very personalized way. In early 2020, SHOW was scheduled to be in the field collecting data in communities around Wisconsin, but with COVID, we were no longer able to proceed in that manner. And at the same time, there was an urgent need to track the early and ongoing impact of the pandemic on population health. As an established statewide community research program, SHOW is uniquely positioned to capture data on how the pandemic and the implementation of new policies and procedures were affecting our participants. Show quickly pivoted to a no-contact approach with online and phone surveys focused on learning about the early and ongoing effects of COVID-19 on health and well-being across the state. The goal of this study was to collect descriptive data on several topics, including perception of COVID-19 risks, individual mitigation and coping strategies, family dynamics and stress, pandemic-induced economic shocks, and the impacts of the pandemic on health and mental health. This data allowed show investigators to capture a wealth of information on how COVID-19 is affecting communities around Wisconsin at 3 distinct time points in 2020 and 2021. Our data show how important the social determinants of health are in understanding COVID-19, and many of our findings show disparities in how the pandemic is affecting communities around the state, including higher rates of testing and perceived infection rates among non-white respondents, higher economic shifts and job changes in female versus male respondents, higher reported levels of overall stress and stress from the pandemic in families with children, and disparities in access to care in rural versus urban environments. For example, in rural regions, there was a lower prevalence of infections early in the pandemic, and also there were fewer reported delays or missed appointments due to COVID-19. So what? So with this data, SHOW has been able to inform research and community organizations alike. We've provided de-identified public use data to investigators to contribute to the overall public health knowledge about COVID-19. We also continue to share relevant information with community partners, for example, local health departments, contributing to community information sources such as UW Health in this recent article, this WPR segment, the latest quarterly publication, and indirect data give backs such as this infographic on antibodies. So thank you so much for letting me talk about this today. If you'd like to learn more, you can go to our Go link, go.wisc.edu/show-covid-data, or contact our team at researchers@show.wisc.edu. Thank you.
Thank you to Laura. Next up, we'll be hearing from Catherine Harris, who will tell us about the use of R to streamline analysis of continuous environmental data. Go ahead, Catherine.
Thanks. So I work at the wastewater treatment plant here in Madison, the Madison Metropolitan Sewage District. And I deal with data that is never ending. It's something that you all help contribute to every day. We all use water, and that water goes somewhere after we use it when you're washing your hands, using the toilet. You can go to the next slide. And that water comes to the wastewater treatment plant. Within 24 hours, it's cleaned up and back in the environment. This whole process is continuous and it just keeps going. That's the beauty and the challenge of the data that I'm working with. It never stops. And through the Data Science Hub, the carpentry classes, coding meetups, I've been learning the program R and how to hook it in with databases that are used in my workplace for this type of continuous data and monitoring. It was a little hard to capture exactly what I wanted to share in one slide and one picture, because the benefits of using R is all about the process. Before, I was doing at least 7 steps to go and see what was the most current data, downloading the CSVs from our databases, a number of different ones, opening those CSVs, formatting them, getting them all together in the right shape, transcribing some things by hand, making graphs from scratch in Excel, emailing those out to my colleagues. So it was really labor intensive. It took an hour or 2 hours every time we wanted to just update one thing that we're looking at. Now, using R, I just have one code, 0 steps to update. The code runs automatically when I open my computer, so it's always got the most current data there. So I can get right to what's most important. it's also so much better for collaboration because my colleagues can view the most recent data just by clicking on an HTML link on their desktop. And we're all kind of on the same page at the same time. Next slide. It's been a huge time savings overall, saved me a lot on the repetitive busy work that we all know about, I'm sure, at one time or another. And my next slide, please. So I'm not doing necessarily groundbreaking work here or anything new or novel with this technology or its applications, but I did want to come to this conference just to connect with others who might be doing similar types of work with continuous data, stuff that requires you to always be updating it, to learn more about sources that are out there. So if there's anyone out there who has experience with R and using and finding weather data, I would love to connect with you. So look forward to seeing you in the breakout room. And just wanted to end and conclude here by saying thank you for all the organizers who have allowed me to be part of this program, and Sarah Stevens for all of her work organizing it. So thank you. It's been very empowering.
Thank you, Catherine. It's lovely to hear the benefits of your work, because I got to see the beginnings of it as well. Next up, we'll hear from Kesong Cao, who will tell us about a deep learning approach to location data privacy protection.
Thank you, Sarah. Hi, everyone. This is Song from Department of Geography. And I would like to thank our founder, American Family Insurance. First, before my talk, I'm going to talk about the deep learning approach to location data privacy protection. Next, please. So as we know, location data has been, has great data utility in public health, in location business support. However, also the privacy concern really, arise big issues for, security and also ethical issues. The location privacy or geo-privacy refer to individuals' rights to prevent the disclosure of personal sensitive locations, such as shown in this figure. And if a classification or clustering of those points, we are able to identify individuals' home location, work location, based on the coordinate information. We further link to address, if also linking to the public, records such as the owner of the house, we actually be able to identify individuals. So maybe it sounds scary. This is why we need, when we deal with those location data, we need approaches to protect the location privacy. Next slide, please. So in this research, we essentially concern in two research questions. First of all, that is more about privacy protection effectiveness using machine learning and more specifically deep learning models to protect the location trajectories compared with traditional statistical models such as geomasking. Second, regarding the data utility, we still want to, reserve the data utility because we want to utilize data science, right, for social good. So this is why we still want able to analyze the data. So this is the workflow we proposed. You can see the consists of three components. First of all, we want to do something from the raw location data to encode it in a way that it reserves the key spatial, temporal, and semantic information in the raw trajectory data through the deep learning model. And then in the downstream tasks, we can evaluate the performance of our model through such as trajectory user linking task or through location clustering, whether be able to still identify the home or work location and other summary statistics. Next slide, please. More specifically, as you can see from the figure above, so first of all, on the left part, we show that the temporal information, the A subpanel shows the original data, and then the B shows actually our generated location data. And from those different types of place types are visited. And then the top right figure actually one raw location trajectory through space and time, and the generated trajectory from our model. And in the table, I actually show you the performance regarding the trajectory user linking, which means that imagine you have millions of trajectories in a database, and then through any arbitrary trajectory, and whether you are able to identify this unique individual. So that's what we call trajectory user linking task. So as you can see that our proposed model has the lowest accuracy to link the unique user, which actually is what we want, because we want to protect the user's privacy regarding, we want to decrease the accuracy to unique linking the user from any arbitrary trajectory. Next slide, please. So in conclusion, from this research, there are several data science related challenges that we want to study and deal with. First of all, how to deal with unstructured data inputs for the learning friendly machine learning model, deep learning models, and then for the domain application usage, how to design a appropriate loss function. So because different from the regular deep learning loss functions such as cross entropy, we want to have a more spatial, temporally explicit loss functions, and how to design effective learning strategies to address the location of geospatial characteristics of the data. And lastly, and how to deal with the unbalanced label data samples, because not like computer vision domain, we have a well-known like ImageNet for the training. In the geospatial domain, usually we don't have such well labeled data. So yeah, that's all. Thank you everyone for listening.
Thank you, Song. Next up, we'll be hearing from Zhao Zhang, who will tell us about an integrated deep learning modeling framework for county level crop yield prediction in support of the USDA NASS operation. Go ahead, Zhao.
Thank you, Sarah, for the introduction. And this is Joe. I'm an assistant professor here in the Department of Biological System Engineering, and our Digital Agriculture Research Lab mainly focuses on using the data science machine learning tools to solve those digital agricultural problems. So today's focus is about developing the deep learning modeling framework for the crop yield prediction. So next slide, please. So why this thing is important? We know that by 2050, so we have like a largely growing population to feed the world. We want to monitor how the crop grows and estimate the crop yield. This is important for food security monitoring, for the resource management and market planning. Also, this is pretty important for the insurance company, for crop insurance, because we want to know have a expectation estimation for a certain region, so we can, if we can know their yield earlier, we can have an expectation of the yield, then we can set up the insurance premiums accordingly. So that's why we need to, this is an important research topic, and we need to use data science tools to solve this problem. And then the next slide, please. And we can monitor the crop yield globally or nationally. Actually, in this project, we are partnering with United States USDA National Agricultural Statistics Service, short for USDA NASS. So NASS has some preliminary work. Actually, they published this crop yield prediction mainly for the major crops in the United States, like the corn, soybean, wheat. But they published this yield prediction at what level? At the state level for each state. So we have one prediction value. Also, their predictions are published, released monthly from August to November, which is from the mid-season to the end season. So we know that, for example, corn and soybean, typically they were planted in May, right? But we won't be able to get this yield prediction in the early season. The right-hand side picture actually shows yield statistics at the yield survey data at the county level. So this is credit given to the USDA NASS. This is a data from their website. So yes, they do have this finer spatial scale yield statistic at the county level, finer spatial scale. However, they don't have this information released until the February in the next year after the growing season. So there's really a research gap here. We lack county level in-season crop yield predictions. So we want to develop models to estimate a county level yield, say within the entire growing season, say from June until November. So next slide, please. And then we work together with USDA and NAS people. Then we developed this research idea, and this work has just been funded by the USDA NIFA Data Science for Food and Agriculture System program. So this is the entire workflow for the whole project. First of all, we gather those public available satellite imagery and some yield data from USDA, soil data, weather data, because all these factors affect the crop growth and automatically affect the yield. And then we develop deep learning models. In this case, we use a Bayesian deep learning because we want to estimate not only the yield, but also quantify the uncertainty for our estimations. And after that, we want to develop transfer learning, or we call it domain adaptation models, so that because we know we don't have ground truth yield records everywhere in the United States. In some locations, we have more yield records, but in some places, we don't have those. So to be able to generate a yield map, accurate yield map for all the place, we want to transfer the knowledge we learn in the regions where we have abundant yield records to the places where we have no or limited yield records. And this issue can be solved by using domain adaptation. And at the end, we want people to use the tools, models we developed. So we are actually collaborating with other faculties to develop this web tool so we can deliver the results to USDA NAS and also for free public use. So next slide, please. This is some of the preliminary results we have been obtained so far. So the left-hand side figure is the Bayesian deep learning model we developed. So we see the feature extraction net, the blue net. Basically, you see we have all those remote sensing, weather, soil, all those data. We stack them together and let them input into this feature extraction net. We extracted some informative features from this deep feature net, and then they fed into both the uncertainty net and the yield net. So we assume the yield follow a Gaussian distribution, so we can quantify the by calculating the standard deviation of the data distribution, we would be able to quantify the uncertainty. And then the right-hand side figure shows the preliminary results we get. So we see that the red line is the Bayesian neural network. Compared with other state-of-the-art models, we saw that Bayesian gives us the best accuracy within the entire growing season, starting from the mid-May until the end of October. So next step, please. And for the next step, to meet our second goal, to be able to have accurate yield estimation for those regions with no or limited yield records, we would develop this unsupervised domain adaptation. We will be able to gather the models trained on those regions with abundant yield records, because those models can be, we have multiple models, right? For each region, we probably train one model. Then we try to combine them and then transfer their knowledge to the regions with limited yield or even no yield records to get the yield estimations in those regions. And then next slide, please. Okay, so after those, we will develop this web-based tool. So we have interface for automatic data acquisition, and then we have middleware database to manage this big data. Then we just also deliver our models, estimation yield maps on this final visualization tool. Okay, next slide, please. Okay, yeah, that's the end of my presentation. We'll come to any questions in the discussion section. Thank you.
Thank you, Jo. Next up, we'll be hearing from Jules Arensdorf and Dave Bloom about Den of Pythons, a co-learning community for non-experts.
All right, thank you. My name is Jules Arensdorf. I use she, her pronouns, and I'm the instructional design librarian at UW-Madison Libraries.
And I'm Dave Bloom, he, him pronouns, science and engineering librarian, primarily out of Steenbach Library.
Slide, please. So why did we start a den of Pythons? Essentially, we will establish a co-learning community that would provide a supportive community for folks interested in learning the Python programming language. Several of us who started the group had experience in traditional expert learner style classroom settings or online courses for learning programming languages. And we had felt disempowered, disconnected, unmotivated. So we wanted to try to learn something new or try something new in which we were all novices and we all had the opportunity to lead, since we found that we learned best whenever we had the opportunity to teach something to others. Slide, please. First, we established group agreements to ensure we were all on the same page with what our goals were and how we wanted the group to operate. We just anchor our group with a shared text, automate the boring stuff with Python, which is available for free online. Working through one chapter at a time would help us keep moving forward, and also provided a means for new folks to catch up as needed, since several folks joined the group after the fact. We also use the same freely available software, Anaconda and Jupyter Labs, and we created installation instructions, which we share with everybody. Also toward that end, the group uses Google Docs to take group notes, and we have a shared syllabus with the ability for anyone to sign up to lead future chapters. Slide.
So here are some things we learned in going forth with this plan. So we did end up splitting responsibilities for leading the sessions and for note-taking, which was super important. So no single person felt consistent pressure on this. Only one person per meeting really has to internalize and successfully work through the textbook chapter. The expectation is everyone tries, but only one person really needs to know it so they can kind of guide the discussion. While the group is consensus-based, it's also been critical for a couple people to take the responsibility of scheduling because otherwise it just sort of falls apart. We assigned readings ahead of time, but we figured out that we needed to plan for catch-up about every 3 chapters or so due to varying chapter length and complexity. We've also dedicated some meetings strictly to reviewing some of the previous material, which has been helpful. It's also been important to pivot where necessary. The textbook we've chosen is pretty good, but no textbook is perfect. We use different software than the author recommends. We skim sometimes when necessary. We flesh out some points where necessary. We Google things to figure out answers to questions that come up. And we've also discussed prioritizing chapters based on interest in the future, such as there are folks who are really interested in spreadsheet manipulation, for instance, so we might skip ahead to some chapters about that. And finally, while textbook exercises are helpful for learning basic skills, it's sometimes really difficult to see the real world applicability. So some of our most interesting meetings haven't been about the book at all, but they've been opportunities for members. And remember, we're all non-experts in the group to share projects for which they've used Python. Slide. So here's an example where I, a non-expert, was able to use the skills I learned in the group along with some strategic Googling to solve a real world problem. So in addition to being a science and engineering librarian, I'm also the Patent and Trademark Resource Center representative for campus. And in December, a researcher approached me with the idea of tracking trademark registrations from 1870 to the present and visualizing them in some way. So the necessary data was available, but it was only available in bulk download files that were much too large for Excel to open. So I ended up resorting to Python. So using Python, I was able to import the data, clean it up, analyze it, and visualize it for the researcher. We've recently rebooted the team with some new members. We're restarting the readings because a lot of us expressed an interest in reviewing and of course all the new members. And we're also adding optional meetings where members can share projects and other ideas as we go along. So if you're interested in joining up or just want to talk to us about creating your own non-expert co-learning community, let us know.
Thank you, Jules and Dave. Next up, we'll close out the set of lightning talks with Ganhua Lu, who's going to tell us about gerrymandering in Wisconsin, tools to understand and improve fairness.
Hi, I'm Ganhua Lu, and I am graduate student in the computer science department, UW-Madison. Slide. And I would like to start today's talk with a piece of news. So this news happens on January 19th this year. So there's an ongoing discussion about making the congressional map more fair in Wisconsin. So why do some people think that the current map is unfair? Slide. So if we look at the vote majority in the current congressional map, we can see that Republicans have advantage in 6 of the 8 congressional districts. And numerically, it raises the public's awareness if we look at the result of the presidential election over the last 2 decades. So what we want to do in this work is to explore if there's a way to generate a fairer map. Slide. So as opposed to the current congressional map, which is drawn mainly based on the existing counties, we generate our maps using a smaller unit in Wisconsin, as shown in the picture. So for each unit, we have its voting data. And what we want to do is to sit down and look at the empty map and draw 8 colors on the empty map to formulate congressional districts that pursue some kind of fairness. Slide. And to generate fair maps, we have to follow some rules. The first one is the population fairness. Population fairness means that we want the population over all 8 districts to not differ too much. And slide. And second is contiguous rule. So for example, in this picture, we can see that the blue district is split into 2 parts, and we want to avoid such thing from happening. Slide. And the third one is the shape compactness. So we can all agree that the map we are looking at does not look good because the districts in this map are long and thin. And instead, we will want it to be round and compact. Slide. So given these 3 rules, we have designed an algorithm that is able to randomly generate multiple congressional maps. And we've also designed a user interface that allows users to evaluate those maps with different objective or metrics. So for example, if a user wants the district ratio to be close to the voting ratio of the 2020 presidential election, then slide. And the slide, in the map I'm currently showing you could possibly be the best map in the data set because as you can see, Republicans and Democrats both have advantage in 4 of the 8 districts, which is close to the 50-50 voting ratio in the 2020 US election. And slide. And I think this problem is really interesting because different kind of fairness definition can be incorporated in the algorithm design or the user picking map phase. And for example, we also have the ethnicity data for each unit in Wisconsin. So maybe some kind of ethnicity balance can also be incorporated in our algorithm design. And currently, we are also experimenting implementing our algorithm on larger data sets, such as California precincts. And to sum up my presentation, I encourage the audience to think more about what fairness means to you in this problem. And I hope that my presentation gives you some insights about the current ongoing gerrymandering in Wisconsin. Yeah, thank you. And the user interface, we built a user interface based on R Shining. So I've noticed that there are a lot of talks about R and R Shining. So maybe if you're interested, you can also look into that. Thank you.
Thank you, Cheng Wei.